Hello and welcome to the AI Research Roundup. I'm your host, Alex. Today is May 7th, 2025. We're looking at an interesting ICLR conference paper titled ReGenesis. LLMs can grow into reasoning generalists via self-improvement, published a little over 3 months ago on January 22nd. This paper introduces a novel self-improvement framework helping LLMs boost their general reasoning, especially for tasks they haven't seen before, what we call out-of-domain or OOD tasks. This figure nicely illustrates the ReGenesis process. So, for a given problem, the model starts with general guidelines, then refines them into task-specific ones. It then builds a detailed reasoning structure to generate candidate solutions. These are checked against ground truth answers. If no good path emerges, the answer subtly guides earlier steps, helping create those correct reasoning paths for fine-tuning, boosting data use. Alright, and speaking of those hints, Table 1 here really quantifies their effectiveness. It compares the proportion of correct reasoning paths for several in-domain tasks, like GSM8K and NumGlu, with and without hints. Well, the numbers clearly show adding hints substantially increases the generation of correct paths, boosting that training data utilization from an average of 96.2% to nearly 99.4%. Building on that improved data utilization, Table 2 now looks at actual performance. It compares zero-shot accuracy. That's how well the model does on tasks without any examples, for ReGenesis against other methods like STAR across 5 different reasoning datasets. Okay, ReGenesis, particularly using self-consistency prompting where multiple reasoning paths are generated, clearly leads across the board. This really highlights its strong in-domain reasoning capabilities. Now, moving from those strong in-domain capabilities, Table 3 here really tests generalization. It shows zero-shot accuracy on 6 different out-of-domain, or OOD, tasks. So, these are tasks the model wasn't specifically fine-tuned on. And what's key is that, while other methods often see a performance drop here, ReGenesis actually improves performance on these OOD tasks compared to the non-fine-tuned model. So to understand why ReGenesis generalizes so well, Table 4 presents an ablation study. This type of study tests different combinations of the method's core parts. Here, the abstract guidelines, structure generation, and path generation. Okay, the results across these diverse tasks show that using all 3 components together, A plus S plus P, yields the best zero-shot accuracy, really confirming their combined importance for strong performance. Following that ablation, Table 7 here digs deeper into the hinting mechanism itself. It compares the zero-shot accuracy when hints from ground truth answers are introduced at different stages. Specifically, it looks at adding hints only during abstract guideline and structure generation, so A plus S, versus adding them through path generation as well, A plus S plus P. Well, the results generally show that restricting hints to the earlier A plus S stages yields better performance, reinforcing careful hint integration. So, to conclude our look at ReGenesis, its self-improvement by creating diverse reasoning paths from abstract ideas to concrete steps is key. This helps LLMs become true reasoning generalists, meaning they perform well across many tasks, especially unfamiliar out-of-domain ones. That's it for this AI Research Roundup. Thanks for listening, and catch you next time.